Let's create the bubbles. Let's turn, I think, everything off apart from the liquid. We'll copy and paste the liquid. Turn the liquid off. We'll rename this geometry node to bubbles. We'll jump inside. And what we want to do from here is generate a load of points based on this surface. But we not only want to generate points on the surface, we want to generate them within. So we wouldn't be able to do that using a scatter SOP. We need to use a points from volume SOP because this is currently scattering points on the surface. So if we use a points from volume SOP, just going to frame that up. You can currently see that 1 point is being created, and that's because our separation distance is too large. So if we just decrease that down to something like, just checking my current settings, 0.002, and we'll make sure the point configuration is set to grid, the construction method is set to dense grid, and we can leave auto detect as is. So that gives us that. So we've got points generated based on a grid. So if we just ramp up the jitter seed, just to whatever random number you want, and then we can just increase the jitter scale, just to add some noise in there, just to break that up. Okay, so what we want to do is we want to delete some of these points like randomly, but we kind of want the points to kind of sort of flow up to the top of the bottle, which you'd usually see in a fizzy drink. So there's multiple ways of doing this, and I'm just going to show you one of them. I'm just going to copy over something that I've really quickly done using similar methods that we've used before. So what I've done here is that I've created a sphere. I've sort of elongated it. You know, so it originally was sort of looking like more like that. So I elongated it, stretched it out. I added the mountain SOP, which created this really weird shape. And I created that 4 times over, varying the height and element size, messing around with that. And then I merge all of those together, which gives me this funky looking shape. And then what I do is I take a group SOP, and this says bounding object. So this is our bounding object, which we want to delete by. So we want to delete these points by these objects. So let's plug this, or these points, into the source data to delete. Let's view from here. We will be running over points, so the group type is points. And what we want to do is turn this keep in bounding regions on. And what we want to do is turn that to bounding object. So now you can see that the points that got selected are the ones within the geometry here, which is really cool. I'm just going to name this group to something like something generic. I think it's something like group points, just like that. Then we'll take a delete SOP, and we want to delete these points based on that group. Take the delete SOP, select our group points. We're running over points there, and now we got some really cool looking points there. I think what we'll do is we'll invert this, or say delete non-selected, and that gives us something even more interesting. So just switching between those two. So in this version, we are deleting the points outside of this surface. If we switch back to delete non-selected, then we're deleting the points within this geometry, which creates a much more interesting look. So there you go, we got some nice flowing shapes there. What I'll do is I'll jump into the small droplets. Let's copy the sphere, the copy to point stop, the attribute randomize. I think that's it. Let's copy those 3 nodes. We'll jump back into the bubbles, paste this down. I'll use Y to cut that line. So hold down Y and you get a snipping tool and you can just cut it. It's kind of cool. I'll pipe the points into the attribute randomize as we sort of did before. We'll plug the sphere into the copy to points. Now we've got spheres assigned to the points that we've just made. We'll also bring over a mountain SOP. So if we just view the sphere, I'll just sort of change the surface of that sphere with these settings. Let's view what we've got, which looks like that. It's looking quite nice. I think I'll change the radius or the height in Y to something like 1.3 so they're not as elongated. So now we've got some really interesting shapes there. And then finally, we'll finish it off just with a normal SOP to recalculate those normals. Let's view from the camera. Let's jump into the material network and we'll create a new material called air. Just like that. I think we'll do a custom one here. So we'll turn the diffuse weight down to 0. We'll turn the BRDF to GGX. Turn the roughness up to about 0.01. The index of refraction to 1, which is the refraction of air. And we'll turn this to thin-walled. We'll also turn the refraction weight up to 1. And make sure this link to reflection is turned on, so the refraction roughness is inheriting the reflection roughness there. And then we can apply this to the bubbles. Let's turn the liquid on. Let's do a test render. And then you can see we've got really cool looking bubbles in there, which are looking really nice. And one thing I'm spotting is that the bubbles are coming through the surface of the liquid a little bit. So what we can do to really quickly fix that is jump into the bubbles. And we'll add a transform SOP down. So we've done something similar to this as we did earlier on. Let's click enter on the keyboard. That brings up the pivot handle. And we want to center the pivot again. So I'll just do exactly as we did earlier on. We'll type $CEX, $CEY, $CEZ. And we'll just scale this down to something like 0.998. Maybe even go a little bit further. Something around that, I think. Let's come back out. Just take a snapshot there. Re-render. And that seems to be looking pretty good to me. I'm just going to hit save.